Hi everybody and welcome to another YouTube video. Today you join me in the wind and hopefully not the rain, but to take you through this 24 panel ground mounted solar PV system with SolarEdge inverter, SolarEdge battery storage and a SolarEdge backup interface, allowing this home to be completely off grid in the event of a power cut. We've got the Cornish rocker system here as well, which is a tiltable system so the customer can alter the pitch of the panels depending on the time of year. But let's go into all that in a lot more detail now. So let's start at the field end. So you can see here we've got these weird bamboo sticks stuck in the ground at random locations. So this is marking out, this is what the customer's done, this is marking out where the Cornish rocker uprights are going to go as per the Cornish rocker design. We've had very little to do with this, to be honest. We've just designed the amount of panels to the size of inverter, and Cornish rocker travel all over the country, I believe, fitting their own system. So they're coming up from Cornwall up to sunny Dunnington to fit this system for us and for the customer. What we've got to do here, we've got to get cables out to this array, and then we've got to fit 24 panels along with our SolarEdge optimizers. So they're going to go on 2 rows of 12. So we'll have a row on the back here and then a row along the front along there. So you can see the customer's kind of marked out the rough territory, so it'll be really interesting over the course of this video to see how all of this changes. We can get this pretty much dead on south facing as well, which is really good, and we have got a little bit of shading here, but obviously with SolarEdge, you've heard me say it all the time, but that helps with the shading issue. It can't remove the shading issue, but it can help optimize the panels that aren't shaded, which might be some of these back ones, so that these ones don't work at the same efficiency of, say, these ones that are maybe getting a bit of a shadow from the trees just there. We'll go into that a little bit more detail probably when we have a look at the system installed and review what we can see on the app and everything. So let's go and have a look inside now, and I'll show you how we're getting on. This is day 1 as well, so we're right at the start of this installation, which is great. Let's head inside. So we are in the plant room / utility room, and we've had a real debate this morning about how to get these batteries and this system installed in the best way for the customer. So you can see here we've got our fireboards, and we've actually got some OSB on this wall first because this is a stud wall. So these battery brackets, which are for the SolarEdge batteries, take all the weight of the batteries. Basically, we're just stopping them falling forward. So these legs go down onto the floor, and then we have a second battery that is stood directly in front of it. But what we needed to do here, we need to consider a trap door. So we've actually got a trap door here, which is quite hard to make up. You can see the joint here, and then it comes along here, and under there's no taps or anything. There are just a few plumbing joints, so I think they've just left them there, left the access there just in case there's ever any leaks or anything. So what we've been considering here is whether or not we put the stand there. I'll show you. So the stand here, and then effectively blocking some of this, or if we were to put the stand on this wall here and move this socket to somewhere else. We've decided to go for this route because it looks a lot better, but also because of the way that these brackets fix to each other, the batteries will actually be held mainly by this bracket here, and then all the plumber or the customer needs to do is actually wind this front leg up in the future all the way up to the top to then actually get this back out. So we're going to go down for that because it falls really nicely on the flooring joists as well, so that a lot of the weight is transferred directly onto a dwarf wall, onto a flooring joist, and it looks a lot tighter than trying to squeeze one in next to this one that we've just put in. So I mentioned that we put some OSB on. We've then put some of our normal fireboards on, some 12mm Hardybackers, just to give it a fireproof and heatproof surface. So then what we're going to do next is we're going to lift this battery in place. Most probably I'll have a chat to Dean. Dean's in charge on this one, so I'll see what he wants to do first. Lift the batteries on there so then we can see what height we're at. Because we've had to lift these legs up because we want to give this front bracket a lot of scope to be the front legs to be lifted to allow this out here, we're going to end up being a little bit higher than normal. So we want to just make sure we haven't taken all of our height from the top here. So Dee's just bringing in the hub inverter now, and we're going to see how much room we've got in a minute. Okay, so you can see I've done the most work that I've done in a while. Me and Dean have carried this SolarEdge battery round, got it on our stand now, and we're just trying to work out where our trunking is going to fall. Like I mentioned, we've had to lift our legs almost right the way up to give ourselves the access that we need for this hatch to come out. That means obviously that we've eaten more space up above than we normally would do. So that's meant that everything's a bit tighter height-wise here. So we're just having a little look at that now to see where our trunking is going to go and how best to work it all out. But this is why this part just takes so long, sort of working through where this is going to go, how the cable's going to come in. And you get back at the end of the day and you look and go, we've put a battery on the wall. But actually, there's been loads of little things that we've ticked off and those little bits that we've worked out that if you just went crashing in, you would maybe come across and think, oh, we have to cross that cable or we have to do this and do that. So the thinking part is really important, and that's why we just tend to take a bit of a long view of it and go, right, where's this going to end up and how is this going to look? So yeah, we're going to crack on and get that trunking on now. So we've got two kind of banks of panels on this. We've got this bank here of 16 panels. It's actually two banks of 8 here, but in one long row. So these are the Perlight 430 watt all black panels that we use on a lot of our jobs, and it's fixed to the Cornish rocker ground mounted system, which we'll have a little look at and go through in a little bit more detail. The interesting thing about this is that it's all adjustable on the tilt. This time of year, we're in November at the minute, so the sun is a lot lower than it will be in July. So these are currently set at 60 degrees. Cornish rocker actually advise the customers on the pitch to set it at depending on where they are in the country and the time of year that it is. So currently these are set to full 60 degrees because the sun is lower, so we're getting a better impact, if you like, of that light when it hits the panels, and yeah, hopefully increasing the generation. This is the first Cornish rocker job we've ever done, so it's been a bit of a learning curve for us. Cornish rocker themselves have fitted the panels and the ground mounted fixings and all of that. We've just attached the SolarEdge elements to it and wired it all in. This is the first bank of 8, and then we have a break here, and then there's another bank of 8, and then behind all this, which we'll have a look at in a minute, is another bank of 8. So we've got 24 in total, which is a peak of, I think it's 10.32 kilowatt peak, and that's all feeding back to an 8 kilowatt hub inverter in the house. So we'll have a look at that in a little while. I'm quite excited to do that because I'm absolutely freezing at the minute. But yeah, really easy to clean. Obviously with them being down on the ground, easy to change any spare parts. Obviously the customer is lucky enough to have this land available, but yeah, it's been a really interesting project. So let's have a little look around the back and I'll show you a little bit more as to how all this is made up and the tiltable aspect of this. So Cornish rocker provide this Allen key, which is an 8, and this magnetic angle finder. So we can see at the minute that this is set at 60 degrees. So this is the maximum tilt that we've got. And this arm here is the arm that effectively sets that tilt. So we've got a grub screw here, and then another one at the far side over there, which then allows this to tilt. So I'm going to do that now for you. Hopefully I don't break it, because I've not done this yet. So we'll loosen that. Wow, that's a tight one. Right, so that's them done. Oh wow. Down to there, and then if that's where we wanted to set it, I won't tighten these up too much because we're going to put it back to 60 degrees for the customer. But that is now set, and that is a pitch of about 25 degrees. So we can go pretty much from 60 degrees to 25 degrees. And obviously in the summertime we can drop this down, or the customer can drop this down, and that'll be better because the sun will be a lot higher in the sky. So yeah, pretty cool. First time I've done that as well, so that is live action. I didn't break it as well, which is fantastic. So I'll put this back to 60 degrees now. The customer was telling me yesterday that Cornish recommend the only bit of maintenance on this is a bit of lithium grease on white lithium grease on this bit here. Obviously that's where you might get a bit of catching in the future as this system gets older. Obviously it's all fairly new now, but I don't think that's too much to ask really. A little bit of lithium grease on that just to keep that flowing nice and steady. Yeah, back up at 60 degrees. So yeah, really cool. It's quite an interesting system, and it was quite interesting to see the parts of how they fix this to the ground. Because we've got this rebar here, which this big, I think it's a 32mm socket, a 32mm nut on here, and they use some sort of jack. I'm sure Cornish Rocker will be able to provide more information on exactly how they did this because we didn't see this in person, unfortunately. But this big bit of rebar here, from memory, they hammer this into the ground, and it's got some sort of like a little anchor on the bottom, and then it's pulled back up through the ground to create that tension. And then there's this big old nut here that's then wound down onto this plate to hold this plate down, which is then in turn holding all of this structure down. But I'm sure Cornish Rock will be able to provide a bit more information on that. But yeah, it's absolutely rock solid, absolutely rock solid. So must be working fantastically. On these panels, like I mentioned, all we had to do was actually fit the SolarEdge optimizers, and obviously we can get to the underneath of all these panels. So you can see we've got the optimizers fixed to what looks like K2 rail, because that's something that Cornish Rocker provided. So we've got our optimizer per panel, and then they're all wired together, and this is wired in 2 strings. So we've got one string of 16, which is this one here, and then one string of 8, which we'll have a look at now. This string of 8 is obviously sat on its own, and the spacing here is just about right. The customers mentioned that the shading at 60 degrees comes to about here at this time of year. It might get a little bit worse as we get further into December and further into the back end of the year, so there might be a little bit of shading, but we've got SolarEdge, so if these bottom ones are slightly shaded, these top ones won't be affected on this string. The effect will be limited. This is exactly the same around the back of here. This is just all ready to tilt, the same as the front one, and adjust. We've installed the cable tray to allow that adjustment, because the adjustment is actually swinging on this pole here. So this bit and this bit don't move. It's the fact that these bits here swing, not these 2 frames here. So that allows our containment to stay in place whilst the actual panels themselves spin. But yeah, really cool, and quite an interesting little installation, and one that we'd love to work with Cornish Rocker again on future ones, and hopefully they generate a little bit of work off this as well, because it'd be nice to see them do well. So we've come inside, and I'm very, very thankful for that because the wind is whipping up outside. But this is the plant room, if you like, or utility room, and this is where we've got all of our SolarEdge equipment apart from the interface, which I'll show you shortly. So you can see here we've got 2 SolarEdge batteries, which on their ticket they're 10 kilowatt hours, but they're actually 9.7 kilowatt hours usable capacity on each. So we've got, what's that, 19.4 if my maths is right, of usable capacity. And then we've got this inverter here. Now I told you a bit of a porky pie before, and that was that we'd fitted an 8 kilowatt hub inverter. That is what is planned for this installation, but at the time of filming they're not actually available yet. So we've put this customer in a 6 kilowatt temporary hub inverter just to get them going. So this allows the customer to be on backup mode, and also to be actually using some of this energy that they're generating. Otherwise it would be sat here waiting for that 8 kilowatt inverter to come out. So the 8 and the 10 kilowatt hub inverters aren't currently available, but they are coming out soon. But let's just, fingers crossed that's fairly soon, because we've got a lot of them that we've got to fit. So I'll take you through the installation. So we'll start off at this cable up here. So we've got our PV Ultra, Doncaster Cables PV Ultra cable coming in. That's a 4-core 6mm, and that brings through the string of 16 panels, which is the front row, and then the string of 8 panels, which is the back row. That comes along with an earth cable to earth the array into that trunking at the far side. Then we've got the 2 DC isolators, one for the front set of panels, one for the back. We've got our DC surge protection in there as well. And then we've got, out of that surge protection here, we come down back into the trunking, and then we've got our already pre-polarity coloured cables that have come out of our PV Ultra. So it's a bit of an offcut basically that we've used to come up and into our inverter. So we've got positive for one string, positive for the other string, and then the same on the negatives. They plug in, and that is what's delivering that power from the panels out in the field into this inverter, and then the inverter takes hold of that and creates it into AC, and then that pushes it into the house to be usable power. We've then got a set of normal 6mm DC cables that come from the inverter down into the batteries, and that is what the batteries use. That's the route the batteries use to discharge the power into the inverter if the inverter needs some more power to meet the home's demand, or if the inverter goes, oh, we're generating far too much power, my batteries aren't full. These are the cables here where the inverter pushes the power down into the batteries. So that's kind of like a bi-directional route for the power to either go into the house or to go from the panels directly into the batteries. Now, the difference with a system like this is a DC coupled system. So that means effectively that the batteries are connected to this system on the DC side of the solar PV array or the solar PV system. So rather than having, like for example in the Alphas that we fit, or the Sonans or the Teslas, rather than having an inverter that just looks after the batteries, we've got one inverter that looks after the solar and the batteries. Now there's a few benefits to that. Is one, you're only buying one inverter. We're only having to get DNO approval for one inverter, so that keeps costs down, and it actually allows you to fit a bigger inverter sometimes on the solar side because we're only fitting one of them. But the other side is that if we take the example of we're going to fit an 8 kilowatt hub inverter here, we've got 24 430 watt Perlight panels out in the field, which is 10.32 kilowatts peak of energy potential generation. If the system is generating or able to generate, because of the amount of sunlight we're getting, 10.32, it means that this inverter, let's say this is the 8 kilowatt, this inverter is able to discharge 8 kilowatts into the house. That's the bottleneck. We can't deliver any more than that into the house. But the extra 2 kilowatts that the solar is producing that the inverter can't push into the house, that extra 2 kilowatts can actually go directly into the batteries at the same time as this inverter pushing 8 kilowatts back. So effectively the inverter can take use of 8 kilowatts of energy and push that into the house, into like an EV or into the cooker or the hob, whatever else is needing that power. But instead of that additional 2 kilowatts or 2.32 kilowatts, if we're generating our 10.32 in the field, instead of that just being wasted, what the system can do is, because that energy isn't having to go through this inverter and then into the batteries, the energy can actually go straight from the DC strings through here and then down into the batteries directly. So effectively you can be discharging the system into your house whilst also charging your batteries because they're connected on the DC side of it. Reach out to us if you want a more in-depth description of that, but hopefully that helps you determine the benefit of getting a DC coupled system a bit like this. If it was an AC coupled system, so let's say we didn't have these batteries here, we had an alpha system just stood here, we would be able to kick out 8 kilowatts from this. That is, the alpha would only be able to see what this solar inverter was kicking out. It wouldn't be able to see this effectively clipped energy that we're wasting, which would be the other 2.32 kilowatts. It wouldn't be able to see any of that. So it wouldn't be able to help the system use that extra DC power because the battery would be connected on the AC side of the system. So that's where a DC coupled system just helps to make the most use of the energy that is being generated by the panels when you've got an oversized array to what the inverter's size is. So that's that part. So that's the DC side of the system. So we've got our isolators, our surge, and then into our inverter. Once the inverter is getting all that power, what it does is it sends it down this chunky cable here and into our AC isolator, through our generation meter, and then back down our chunky armoured cable in this case, all the way back to our interface, which is the part which monitors the import-export of the property and also will put this full site onto this battery system in the event of a power cut, meaning that the lights will come back on, the computer will come back on, and everything else will come back on in the event of that power cut. So we'll have a look at that next, and we'll even do a little power cut test to show you how long it takes for the system to come back online after a power cut and what the whole process is, what lights you're going to see, and take you through all of that. Let's have a look at that now. So we've made our way into the home office, and this is where the original home distribution board is, which is just around this corner. That's got all the home circuits in. It's where our new renewables DB is, which is a little two-way Hager board, which is a little bit further down there, which just has the circuit for the solar PV system that we've installed in. So nothing too exciting. The real exciting part is this bit here that I'm going to show you now. So this is the backup interface from SolarEdge. This is our first one that we've installed, and this will take the property off grid in the event of a power cut and allow all the lights and sockets and things like that to start be re-energized through our SolarEdge inverter, batteries and panels, basically. So we go on to effectively the home's own generator, but a renewables generator, which is nice. So what we've got on here, firstly, we've got a couple of lights. So we've got on grid, which is lit up in green, and that's just showing that we've got a grid connection into the property. So effectively this backup interface is just monitoring import and export and feeding that data to the inverter. Backup isn't illuminated. Comms, which means that this is communicating with the inverter, is alive and well, so that's fine. And fault, there's no fault light, so we haven't got a fault. So that's all nice and straightforward. Before I go into how the backup interface is all connected, I'll just show you the other bits we've got. We've got a solar PV isolator as per the regs. We've got local isolation here for the solar PV system, which allows any engineers to turn that off and know that they're not going to get any backfeeding energy from the solar and battery system. We've then got some Henley blocks here, and that is allowing this interface system to operate with our renewables DB and our home DB that was here originally. So how is this backup interface connected? There's a few things that happen with this. I'll explain the wiring first. So from your main electricity meter, which we fitted a 100 amp wireless disconnector with surge protection in there, that's in the meter box. From that, it comes in some 25mm meter tails into the bottom of this backup interface and connected into the supply side. On the outgoing side, we have another set of meter tails. They come down and they go into our 100 amp Henley blocks just here. From these Henley blocks, we have a set of tails that goes to our new little Hager board, which supplies our solar PV system and battery storage system, and our original house DB. So that means that this is sat in line with the main meter tails, which allows it to disconnect those main meter tails in the event of a power cut and put everything onto the battery and solar PV system without risk of backfeeding any energy back to the grid, which obviously we don't want if someone's working on those damaged cables or it's a planned maintenance. So that's all complies with all of that. But also it allows this to be the Modbus meter. So you might have seen on some of our other videos, we have the little see-through box. This effectively replaces that box because this physically monitors the import-export for us instead of having that Modbus meter. So it replaces a piece of equipment. So it kind of has two functions. The other thing we have with this is we fit an earth rod into the system here, and that goes back to the main earthing terminal. So that comes into this Henley block we've just got just here. So that is a reference to earth under 200 ohms, and that allows us to be confident that if the property goes into backup mode and there's a digger that's taken up the full line into this property and taken the earth out as well, then it means that we've still got a reference to earth that is under the customer's control. So we aren't worried about losing our main earth into the property, because the last thing we want is to bring all the power back on in the property and find that all the metalwork hasn't got an earth and the customer get a shock. So that's why that earth is important. And it's also important to make sure we've got some RCD protection on the property as well, which this board has got anyway, so we're okay with that, just in case we go onto a full earth rod protected system, which we've got, so that's all fine. So what we're going to do next, and this is always nerve-wracking, we have done this before, so I know it works, but we're going to show you now the simulator power cut, and we're going to turn this light on in here so you can see when it goes off, how long it takes to come back on again, and also what the customer gets on their phone to show them that the power has gone off or come back on. I think from what the customer has said, they just get a push notification to say the power has now been reinstated, but we're going to show you that all live anyway, so we can see what you get. So yeah, we're going to do that next. Okay, so we're going to do our test now. So you can see we've got this light on here, so this is going to be our reference as to how long the system takes to bring the power back onto this house as soon as I turn that switch off. So in a minute I'm going to walk past you, I'm going to go and turn that main switch off, and you'll see this light go off, and then as soon as that comes back on, we know that we are running on the solar and battery system as it stands. So I've got the customer's phone here as well, so we'll be able to track any notifications that come through, so you know what you might get if you were to get one of these systems. So I'm going to go and do that now, and then I'll come back in here and talk you through the whole process. So back in a minute. In the meter box now, so power's going off in 3, 2, 1. So that is the power off. You can see we are still in darkness. We've got no notifications come through as yet. Aha, there we go. So there's nothing that's come through on the SolarEdge app to say that, so that might be a future update to let us know that we've gone into backup mode now, which would be nice because then it allows you to alter your usage in the home to say you are now in backup mode, you have this much time left. So that would be quite nice to be something I'll be suggesting to SolarEdge. But we are in backup mode now. So there's a few things that have changed. We've gone from on-grid to backup, so we can see there's a little green light there in backup mode now. We're still getting information coming through on the app because the internet is on and everything else like that, because we're on a whole home backup system. And yeah, we're running on the solar and the battery now, which is really cool. This would obviously last as long as the battery had energy or the solar was generating, and it could cover the house's load. If it got to the point where it couldn't cover the house's load, or the sun went in, or the battery, emptied, then you go back into power cut. Within the app, which we'll have a look at in a minute, you can actually set your backup reserve. So I'm actually showing you that now whilst we're in the app. So you can see on this screen here, we're currently at 10%. There's a little toggle bar that basically allows us to slide that up and down. So if you've got a planned power cut that you've been notified about, you could take this right up to 100%. And that would mean that the full battery capacity will just be reserved for when you go into a power cut. 10, 20, 30% is kind of standard, depending on the size of your system and how much load you have. And we can obviously help you to advise you on that, but you might want to change that for different times of the year as well. You might want to have winter time at a higher percentage than summertime because the weather's a bit better in summertime, so less likely to have storms and things, but you can change that around. Okay, so I spoke too soon. We have got a notification that's come through. So you can see here, we have you backed up. There is a power outage, but don't worry, SolarEdge is keeping your energy going. Your battery is 12% charged. To extend backup time, turn off non-essential appliances. So that's really cool. So that's getting a notification. So you might not be at home when you get that. So at least you know that there has been a power cut. And there's also a similar one that comes up when you've had power reinstated. So you'd know that if you're out and you get that, it might be 5 minutes later, you get another one to say power has come back on. You can obviously investigate that when you get home to make sure it's nothing untoward with your supply, but usually it'd just be a grid outage due to an issue on their side. But yeah, that's really cool. And I'll show you now what the app looks like when we're in backup mode. So we can see here on this app now that we've got a big X where the pylon is, your right hand side, and we've then got here backup mode, 6 hours and 44 minutes of backup potential, 13%. That's because the battery is charging. So we've got 1.6 kilowatts of solar being produced. There's only 220 watts of energy being used in the home. So the battery's actually charging at 1.8. So that, you can see now it's 6 hours and 48 minutes. So that's going up and up as we're producing more power. So that's just jumped again because we're putting 2.36 or 2.72 into the battery. So you can still have the batteries charging even when you're in a power cut situation, which is really cool. So we're going to turn the power back on now, get this home back onto normal operation, and yeah, move on to the next part of the video. So I'm going to turn the power back on now for the grid, so we can see we've got the lights on. That's all running from the SolarEdge system, and I'll show you the transfer time over on that, but it should be a lot quicker because the system isn't having to check that the inverter's okay, there's enough power in the batteries. All it's doing is it's going, okay, grid's come back on, we can disconnect from our inverter for doing the full home and just rely on the grid. So it should be a lot quicker of a transfer. So I'm going to go and turn that main switch on now, and keep your eye on this light. So there we go, transferred across already. So we're now back onto grid mode. We've got a notification that will probably come through on our phones any minute now to say we're back on normal mode, and we've got our green light on our grid connection. Okay, another YouTube video all wrapped up, and another installation all wrapped up as well. So that is a 8 kilowatt in the future SolarEdge Hub inverter installed, 2 SolarEdge batteries, 24 430 watt panels with a 10.32 kilowatt peak of energy, Cornish rocker system installed, and backup interface with an earth rod for the added earthing protection. All this together has been a massive learning curve for us as a company and as a team, but also a new video for you to see with new products and new ways of installing it and new functions on apps and loads of cool stuff like that. But if you like the video, then please do press like, subscribe and all that jazz to help the channel grow. It means a lot. This system is making a big difference to these customers' energy bills, even in the depths of November, December like we are now. So if you're interested in the system, then please let us know. We are operating from a waiting list system, but if you want to be added to that waiting list, then drop us an email to info@ovalrenewables.com and we'll get you added. Thanks for watching, and we'll see you on the next one.